So welcome everyone to this new video. In this video we are going to study about the motion of bodies in contact. Okay, in our first case we will study about when two bodies are in contact. Now you can see from the figure that M1 and M2 are placed together. Okay, they are in contact and there is a force F which is applied to the body M1. Now the body together will move with acceleration. Now let us suppose this acceleration is a. Now what is the value of that acceleration? That is very easy. We are going to find it from the Newton's law. F divided by m1 plus m2, because the body will move together as a whole. That's why m1 plus m2, and this is the common acceleration of two of these bodies. Now the acceleration is also the representation of the force per unit masses. Just keep it in mind. Now if the acceleration is a, then what is the force to this mass m1? As the mass m1 is also moving with acceleration a, and m2 will also move with acceleration a, then what is the force on m1? The resultant force, the m1 is m1 into a, and what is the force on m2? The force on m2 is m2 into a. So these are the individual forces which is applying on these individual bodies m1 and m2. Now if you are told what is the force acting between these two bodies m1 and m2, now you know this m2a is applied by the mass m1 to m2. So this force is applied by the mass m1 to m2, and m2 will create an opposite force to that m1. Now this force is F. Now what is the value of F? Simply the value of F will be m2 into a. m2 into a. So the force acting between these two bodies is F, that is m2 into a, which is equal to m2 into F divided by m1 plus m2. So now if you are told what is the force acting between these two bodies, now this is the answer: m2 into F divided by m1 plus m2. Okay, and what is the acceleration? We have already found it. This is the acceleration, and this is the force acting between the force acting between the two bodies, and this is the common acceleration. Now this is the first case, and it is very easy case. Let's move to the second case. Now let us consider our case 2, when three bodies are in contact. Now you can see from the figure that m1, m2, m3 are connected. If the force F is applied to the body m1, now you can see, or you can say that these three bodies m1, m2 and m3 will move together with an acceleration a. Now what is the value of that acceleration? The value of that acceleration will be F divided by m1 plus m2 plus m3. It is very easy. Now what is the individual forces? On M1, the force is M1 into A. On M2, the force is M2 into A, and on M3, the force is M3 into A. Now, if you are asked what is the force acting between these two bodies, M1 and M2. Now, you can see from the figure that the forces on M2 is M2A and the forces on M3 is M3A. So, these total forces M2A plus M3A is coming from this surface, and because this is the only contact of the rest of the bodies with M1, that's why the force acting on these two bodies M1 and M2 will be M2A plus M3A. Now M2 plus M3, value of A is M1 plus M2 plus M3. So this is the force acting between this M1 and M2. Now there will be a opposite reaction force which will be acting on M1, but now don't be confused between these reaction force because these are acting on different bodies. Now if you are asked what is the force acting between these two masses M2 and M3, so you can see that the forces on M3 is M3 into A, and these forces are coming from this surface. That's why the forces, that's why the forces acting between these two masses M2 and M3 will be M3 into A. That means F3 will be M3A, and that is equal to M3A means F divided by M1 plus M2 plus M3. Just close it a bracket. Okay, now we got these three equations. The first one is the common acceleration, and the second one is the force acting between these two masses M1 and M2, and the third one is the force acting between M2 and M3. Okay, I think you understood this. Let us move to our next topic. So now this is our third case, when two bodies M1 and M2 are connected by a string and the force F is applied on the mass M2. Okay, so as the force is applied on the mass M2, and say that these two masses will move as a whole with an acceleration A. Oh, now what is the value of that acceleration? The value of that acceleration will be A equal to F divided by M1 plus M2. So this is the acceleration. Now what is the force acting on M1? The force acting on M1 is M1A, and the force acting on M2 is M2 into A, and this force M1A is provided by that string. Okay, so this is the, if this is the tension, now this tension will be equal to this M1 into A. Now we can say that there will be the opposite reaction force that M1 will create on M2, that will be also equal to T. So the tension of this string will be M1A, that is M1 F divided by M1 plus M2. So this is the tension of this string, and the common acceleration is F divided by M1 plus M2. So these are the two equations we got from this case. So hope you understood these three cases, and in our next video we will discuss about the police.